The submission is from Bauer Outage, who is asking about some jello in his HD cam. Um, let's take a. So I'm not going to play the video for you. You can go ahead and watch it if you want to in the original post. I'm not 100% sure that the jello would get picked up very clearly by my screen capture software, but it is very clear that there's some jello going on. So jello is high frequency oscillation or vibration that is interacting with the rolling shutter of the camera to produce what we know as jello. So let's take a look. Oh, as you know, if we got vibration problems, the first place to look is at the gyros. And in general, any tuning problem, we should look at the gyros. And we can see that in large part, the gyro lines are very thin. There's a little bit of noise on yaw, but not anything to speak of. We can see that there are times when you're doing more aggressive maneuvers where there is some wobbliness, which isn't necessarily a problem. We do see the yaw line get a little thicker here, but I would say overall it does not look like your copter has a problem with excess vibration. The gyro lines are very thin. Let's check your filtering. Gyro LPF is off. Okay, so gyro soft LPF is 60. So this is somewhat filtered. It may be the case that you have a little more noise than is showing up here because of the filtering, but I mean, I think that these are so clean that there's no reason your camera should have jello with lines this clean. I mean, there are many people who are flying with these exact same settings and have fine HD cameras. So where to go from here? We can certainly take a look. Like let's just take a look at your D terms, because D terms will amplify any noise that is present. And we see some high frequency components in your D term. That's these very narrow up and downs. But I'm skeptical that that is the issue that we're dealing with here. And I'll tell you why I'm skeptical of that. First of all, let's take a look at your motors and see how much of these high frequency components are making it out into your motors. And you can see not very much. So the magnitude, the y-axis on these different traces is not consistent. They're scaled up and down. So although these look like very big oscillations, in fact, when we look at the motors, we can see that they're not. And also bear in mind that high frequency oscillations like these, the motors can only respond so quickly. So the motors are not actually oscillating that fast. They're not actually passing those vibrations directly through. So I just don't think that's the cause of your problem. And in fact, I don't think the cause of your problem is likely to be tuning related at all. Just because, like, if we would see fatter gyro lines if you had a problem with excess noise, excess oscillation. Yeah, I've got some spikes here. You might could lower pitch D a little bit. These spikes here may be a little excessive. Alternatively, you could do some D-term filtering. Where's your D-term filter set to? There it is. Okay, so you haven't got any D-term filtering. So try either using some D-term filtering a little bit or changing your D-term average count to be a higher number. That's something you could play with. I don't think that's going to be very fruitful because at the end of the day, tweaking those values is based on the assumption that the D term is causing oscillation that then is showing up in your camera, vibration that's showing up in your camera. But that vibration would also show up in the gyro, and we're just not seeing that. It's possible that the gyro filtering is causing us to not see vibrations that are present. That's the only thing. If that was the case, then the vibrations would get picked up by the camera, but the gyro's filter would filter them out so you wouldn't see it in black box. So I think that's worth trying. Change your D-term filtering, but I don't know if that's likely to bear fruit. Then, of course, the other thing to look at, you could certainly look at, put a fresh set of props on if you haven't. I'm sure you have. Check the balance of your motors. I think you said you've done that. Yeah, so your motors are clean. Definitely check your vibration with the props on. Do that safely. Okay, you're going to spin the motor up with the prop on. Restrain the copter securely, or if you really want to, you can put the prop on upside down on the backwards. Switch the props left to right. Put them on upside down and reverse the motor direction. That makes the prop push down into the ground instead of pulling up. That's one way to do it. It's a little bit of a hassle. Or just restrain the copter securely with like a ratchet strap or some rope or something, and then spin them up and see, how that does. If you see more than about, I would say 0.30 with the prop on, 0.25 to 0.30 maybe with the prop on, that would be suspicious to me. But that's so, I mean, you got to check that stuff. You got to check that stuff if you're getting vibration. The other thing is, is this a 6-inch or is this a 5-inch copter? If this is a 6-inch copter, I've had more problems with jello than on 5-inch because the props make lower frequency vibrations that are more likely to get through. And then also take a look at your camera. If you've got your camera hard mounted, maybe put it on a little bit of foam and that may help a little bit. So those are the things I would look at. Last thing, always look at yaw when you've got vibration issues. Nah, yaw looks fine. Nothing to change here. Obviously, D is very low. D is actually at 0, I think, or very low. And P is not doing anything untoward, so no problems there. So maybe decrease D on pitch a little bit, but that I don't feel like that's hugely likely to be the issue. Or play with the filtering options on the D term, which, as I showed you, are where are they? Oh man, I just had them. It's a D term cut hertz and then the D term averaging. All right, hope that's helpful and happy flying.